So we can calculate the pH if we know the hydronium ion concentration. We can also calculate the hydronium ion concentration if we know the pH. So, why is there a minus in front of the pH? Because we need a negative in there. So this equation, 10 to the minus pH equals a hydronium ion concentration, is just a rearrangement of pH equals negative log of the hydronium ion concentration. So I'm just going to go through this quickly. If you don't like math, just think about something else. So pH equals negative log of hydronium ion concentration because that's what they decided pH was going to be. There's no explanation for that. But I want to rearrange this equation. So the first thing I'm going to do is I'm going to move the negative sign to the other side by multiplying both sides by -1. So now I've got negative pH equals the log of the hydronium ion concentration. Now I want to get rid of log. I can't divide by log because it's a function. I have to do the opposite function, which is anti-log. Anti-log is 10 to the x. So I'm going to take 10 to the x of both sides. So 10 to the negative pH is equal to 10 to the log of the hydronium ion concentration. Well, 10 to the log of something, those poof cancel out, and that equals the hydronium ion concentration. If you didn't understand that or you don't get it, that's okay. That's where the equation comes from. That's why there's a negative sign there. So how do we use that? Well, if I have the pH, let's say the pH is 7.54. That's the pH. How do I find out what the hydronium ion concentration is? I use this equation. The hydronium ion concentration is going to equal 10 raised to the negative 7.54. So you need to make sure that you know how to tell your calculator to do that. You're not going to be able to use your EE button to do this because it's going to give you problems because it's not going to want the decimal point there. So you need the 10 to the x button. On the 36X Pro, it's the button right below the log button. On many calculators, it's the alternate function on the log button. On my calculator, I press the function button first, so I press the E and 10 button, and I press it twice to get the 10 to the exponent. And then in the little box, I'd go minus 7.54, and I press equals.
Now, where is it asking for the pH of OH? The P of OH.
We'll talk about POH in a minute. So this then is equal to 2.884 times 10 to the minus 8, or 2.9 times 10 to the minus 8 molar. That's the hydronium ion concentration. So it's great if you understand the relationships, but the minimum is just be able to plug the numbers into your calculator and get the answer. So let's do this calculation. Calculate the hydronium ion concentration for a solution with a pH of 3.87. I'm going to use that equation. The hydronium ion concentration equals 10 raised to the negative pH. So that is 10 to the negative 8.37. I do that on my calculator, and my calculator is going to show me 4.265 times 10 to the minus 9 molar 2 sig figs, so 4.3 times 10 to the minus 9. Any questions?
What if, like, my calculator just shows a bunch of zeros and 4, so I have no other sig fig to go off of?
Make it display it in scientific notation. Most calculators can do that. I know that one can.
How do you do the 30XA?
On the 30XA, it's super easy. It's the second function of the 5 button. So it says SCI. SCI, it'll put everything in scientific notation, and second FLO, it'll do everything in decimal notation. So if you need help with your calculator, ask me in lab, because the more you know your calculator, the easier it is. Yes?
I'm having the same problem sheet. How do I get the TA36X to show the answer?
Well, I'll come around and show you during lab, okay? That one's a little too complicated to just tell you, but I'll come show you.
All right, thank you.
Any other questions? So we have a pH scale. There's also a POH scale. That lowercase p just means negative log of. So POH is the negative log of the hydroxide ion concentration. It's the same formula, but instead of H here and H plus or hydronium here, it's OH and OH minus. The relationship between these is actually very simple. We know that the hydronium ion concentration times the hydroxide ion concentration is equal to 1.0 times 10 to the minus 14. That was the first equation we learned. I can derive a relationship between pH and POH from this equation by taking the logarithm of both sides. So if I take the logarithm of this thing times this thing, then instead of multiplying, I'm adding. And again, if this doesn't make sense to you, it's okay. But some of you are interested, and so I'm going to go through it quickly. For logarithms, you add instead of multiplying. Okay, so what's the logarithm of 1 times 10 to the minus 14? Just minus 14. Not a trick question, just minus 14. I took the logarithm of both sides. So the log of that is minus 14. And I don't like the minus, so I'm going to multiply both sides by negative 1. So I'm going to get negative log of the hydronium ion concentration plus the negative log of the hydroxide ion concentration is equal to 14. This right here is pH. This piece is POH. pH plus POH equals 14. If you didn't follow the derivation, don't worry about it. But this is a very useful little relationship. pH plus POH equals 14. So that's a good one to know. And this guy here is a good one to know. So what if they give us the POH? The POH is 4.25, and they want to know the hydroxide ion concentration. That equation is going to take the same form as the hydronium ion concentration equation. So we just got done learning that. Hydroxide ion concentration is going to equal 10 to the minus POH. They gave me POH. I can calculate hydroxide. So this is 10 to the negative 4.25.
Why did they just give you the
Because they don't know the pH, they just know the POH. I don't know. Actually, it's harder if you want the hydroxide ion concentration, it's harder if you start with pH. You have to do 2 calculations. So this is going to be 5.6 times 10 to the minus 5. That's the hydroxide ion concentration. Feel like you're drowning in equations? Or lost in a forest of them? Yeah.
Will these be given on the final?
No.
So no logs in the final?
No, I think there's logs on the final. Okay, so I want to show you something. I've got it on the board here too, but I'm going to show you on the screen. It's what I call the circle of pH. So there are 4 things we've been calculating. All right, we've been calculating pH. I should probably do it the same as I did over here. We've been calculating the hydronium ion concentration. On the board I wrote hydrogen ion concentration, but we understand that that is the same. We've got the hydroxide ion concentration, and we've got POH. This is not being very symmetrical here. I'm going to move that. So this is what I call the circle of pH. Those are the 4 quantities that we calculate, and there are relationships between them. As I've drawn them in the circle, you can start at any point on the circle and go all the way around in either direction, but it's not a good idea to try to jump across. If I've got pH and they want hydroxide ion concentration, I don't want to try to make something up and go across. I'm going to go around. I'm either going to go around to the left, or I'm going to go around to the right. And so the relationships here, if I have pH, if I want pH, it's the negative log of the hydronium ion concentration. If I have pH and I want hydronium ion concentration, I use the rearranged form of that, 10 to the negative pH. If I've got hydronium ion concentration and I want hydroxide or vice versa, I use this equation. That's a 4. If I want to go from hydroxide to POH, POH equals negative log of the hydroxide ion concentration. Hydroxide ion concentration equals 10 to the minus POH. Do you see that these 2 equations and these 2 equations are almost identical? Just swap out H and OH. So that's not really 4 equations you need to know. It's just 2. And if you're good with math and can rearrange equations, you only have to memorize the 1. And then up here, this is what I showed you, a derivation from this. And this is my favorite because it's just very simple. pH plus POH equals 14.
But what if you're given pH and you need POH?
If you're given pH and you need POH, just stick pH in here. POH will be 14 minus pH. I didn't rearrange these because you should be able to rearrange that. pH plus POH equals 14. So if pH is 8, POH must be 6. They have to add up to 14. So this is the circle of pH. Which always makes me think of the Lion King. Okay. Very useful.